Let me say to start off that Scott and I think we're put on this panel because we supposedly represent two sides of the story. That's not really true. Scott and I have a lot more in common. We both recognize that silicosis is a very dangerous condition. It's a debilitating disease. It can be fatal. And clearly it is everybody and every employer's responsibility to ensure that American workers are not exposed to silica at levels that can be a health problem. I'm really here as the current sitting chairman of the American Chemistry Council Crystalline Silica Panel, which is a group that's been around for about 20 years, whose sole goal is to ensure that silica regulation is based on sound science. I guess we don't have a remote. I'll use the arrow. I'm going to go through a little bit of some of the same things that Scott said, but get on to some other points clearly that may disagree a little bit with what Scott has said. Crystalline silica is the most common, one of the most common minerals on Earth, represents 12% of this Earth's crust, and it's used everywhere. It's used in industry. There are exposures all across the environment. Its most recognizable form is beach sand, quartz. Quartz is just about 100% crystalline silica. But it's also a very critical material for in many, many industries. I think I just went too far. This slide is actually a mistake. I jumped the gun. The silica standard, the proposed draft regulation, is currently still at the Office of Management and Budget to update the date that Scott gave you. They're thinking probably that they may propose a regulation in August now because OMB has not completed its review quite yet. But what we're expecting to come out of it is a full-blown health regulation very much along the lines of the asbestos rule that was passed many years ago. The centerpiece of the rule is expected at this point to be a 50% reduction in the permissible exposure limit from 0.1 milligrams per cubic meter of inhalable, 0.1 milligrams of inhalable crystalline silica per cubic meter, cutting that in half to 0.05 milligrams. That OSHA had at one point talked about 0.075, but it's likely to be half the current PEL. The expected provisions, clearly most of you are familiar with most of the full-blown health regulations, monitoring, engineering controls, respirator use, medical exams, the whole list up there that you see. Again, going back to the uses of crystalline silica, very pervasive throughout manufacturing and construction. Foundries, obviously, as molds, abrasive blasting, which is an industry that even we don't claim to I just did something wrong here. What am I supposed to do? You know, people who are using sand in abrasive blasting situations better be in moon suits and likely ought to find another material to use. Paint manufacture, glass manufacturing, where it hits me is refractory materials have about half the refractories in the United States are clay-based and would have a silicon component in them. Construction obviously would be very seriously impacted. It's likely that OSHA, when it comes out with a regulation, will have separate requirements for mobile work sites like construction. It's also interesting to note that OSHA will not have a regulation for agriculture. And there are high silica exposures in agriculture, but there's really very little way to control that. Silicosis is an occupational disease. I want to stress that There's been no real reports of there being any kind of adverse health effects from environmental exposures. In the last 50 years, I said Scott pulled out Frances Perkins on me there, the little old lady in the hat. Actually, I worked for OSHA when we moved into the Frances Perkins Labor Department building. We have known about silicosis since the Romans built the aqueducts. Clearly, the Labor Department has known about silicosis and silicosis exposures and the consequences or possible consequences of that for many, many years. It's interesting to note, and Scott mentioned the number 2, silicosis has declined. The incidence of silicosis mortality has declined by 93% from 1968 to 2002. And let's look at that in a graph. This is a pretty significant drop. You know, it's the kind of drop that you see when you talk about the death of World War II veterans. It's just, you know, we're getting to the point where it's very low because there aren't many people left. And there aren't many silicosis deaths reported, relatively speaking. Now, remember, I've said that silicosis is a debilitating and sometimes fatal disease, and we ought to eradicate it. No silicosis death is acceptable, but the trend is downward. That last date on that slide is 2002, and we're heading in the right direction. The current PEL, as I said, is 0.1 milligrams per cubic meter of air. This has been, well, it's equivalent to that. As Scott said, there was I keep going, am I wrong? No. It's actually a different formula at this point, and in the new regulation, they will update it to 0.1. It's roughly equivalent to 0.1 milligrams per cubic meter of air. We maintain in the Silica Coalition, and I maintain, that the current permissible exposure limit of 0.1 is protective of human health. One of the problems we have, well, we have 2 or 3 problems. Number one, the statistics we see are counting deaths a couple of ways. Number one, you are seeing some confounding of the numbers because of other exposures like smoking. So some of those silica reported deaths are not necessarily silica related, although there may be silica present. But also, OSHA is not enforcing its current permissible exposure limit, and employers are not complying with the current permissible exposure limit. OSHA itself did a special emphasis program on silica about 10 years ago now, and found that in 30% of their inspections, the permissible exposure limit of 0.1 was being exceeded. We maintain in the Silica Coalition at ACC that if the current permissible exposure limit is adhered to and complied with strictly, that there will not be the kinds of silica exposures that would result in silicosis cases. All right, I skipped it. I'm going to skip some of these slides. This is an argument we had about OSHA not giving us a chance to look at their risk assessment. They had at one point said that the public would see it. They have gone back on that. The significant risk issue, Scott mentioned that silica exposures also are suspected of causing cancer. IARC has said that it's a known human carcinogen. IARC is the same group that just said that your cell phones cause brain cancer as well. So we tend to disagree. We don't disagree with IARC that it causes lung cancer. We do maintain that it is very unlikely that you will contract lung cancer from silica exposures without first contracting silicosis. That's a very important position that we're taking there. If you protect against silicosis, we believe you protect against lung cancer, number one. And remember, I'm the first to say that we have to prevent every silicosis case we can possibly prevent. But the second issue is that there is some literature out there now, and some studies have been done that apparently point to there being a threshold for not only silicosis, contracting silicosis, but certainly for contracting lung cancer. And that threshold is some point above 0.1. For silicosis, there is a study that says you won't see silicosis cases below 0.15. And there is another study that we've recently seen that says that lung cancer won't occur below 0.4. So we maintain, and I think there is a legitimate discussion and case can be made that if you protect for silicosis at 0.1 milligrams, you also protect for lung cancer. Now, you have to remember that in all these studies that have been done for years and years and years, there's not been a lot of taking into account confounding measures like exposures to other properties like radon or particularly cigarette smoking, which is the big issue. There's another example. The month did a study of 18,000 German porcelain industry workers, found no association between exposure to crystalline silica and any cause of death, including lung cancer, and no statistically significant relationship between average exposures to respirable crystalline silica below 0.15 milligrams. A little bit about technical feasibility. Let me explain. It's hard to envision what 0.1 milligrams per cubic meter of air is, but that is 1 gram of inhalable. Inhalable means it gets into your lungs and can't be exhalable. So inhalable is what sticks in your lungs. 1 gram of inhalable crystalline silica suspended in a cube that's 10,000 cubic meters. I can't do the math. I tried to do it this morning to see what that meant in here. But that roughly comes out to a teaspoonful of inhalable crystalline silica suspended over a football field to a height of 30 feet. That's a very, very small amount of material. A football field up to 30 feet, 1 teaspoonful of inhalable crystalline silica. The 0.5, if you adopted 0.5, that then becomes a teaspoonful of crystalline silica up to 60 feet over a football field. And if you assume that there is an action level that is also often included in OSHA regulations, and the action level is usually 50% of the permissible exposure limit, you're talking about 0.025 milligrams, you're now up to 75 feet above a football field, 1 teaspoon of inhalable crystalline silica. The economic impact, we see that it probably could affect 2 million jobs. The construction industry, you all know about, it's not back on its feet yet. We have been looking at what OSHA looked at for the economic impact of this regulation at 0.05, based on the draft standard that Scott talked about in 2002, 2003, and preliminary numbers I've seen say that it might cost $3 billion a year. OSHA, I believe, was talking about $600 million 10 years ago. But OSHA counts things badly as far as we're concerned. They think it takes one industrial hygienist 1 hour to determine whether or not there's a silica exposure. And we know that it's usually a day or two of work, and they charge you for travel time and everything else. So it's a very expensive process. Now, I think I'm just going to skip ahead to the conclusion here so we can maybe have some questions. Let me be clear again about what I'm saying, and that is that, number one, crystalline silica is a bad actor. It is something that must be controlled. It's something that you must be aware of in your daily lives at work. Employers have an obligation to make sure that employees are not exposed at levels that could be of consequence. Clearly, OSHA has an obligation to enforce its current PEL, and employers have an obligation to comply with that PEL. Employers also have an obligation to ensure that their employees are in a safe and healthy work environment all the time. We believe that if OSHA enforced its current PEL and using its general duty clause, as well as it has respirator standards already, it has enough tools in its quiver at the moment to deal with this issue. You've seen the trend come down from 1,500 cases a year to deaths a year to something about 140 or 150. We think that number is even lower. And it's just not, as far as we're concerned, the time to think about lowering that PEL and cutting it in half, going from 30 feet above the football field to 60 feet. I think I'll leave it at there, and I guess we have time for questions, right, Scott? Thank you.